Okay, the quadratic formula. If we were to take this formula, ax squared plus bx plus c, and we were to go through the process of completing the square, meaning we were to say, take ax squared plus bx equals negative c, like put it over on the other side. And then if we were to divide through by a to get x squared plus bax is equal to negative c divided by a, and then we were to go through and try to find out what is it that we add to complete the square. If we were to go through that completing the square process that we did from yesterday, or that formula, you come up with this guy right here. Okay? And it's something you've seen before, you maybe didn't know where it came from. It comes right from this through the process of completing the square that we did yesterday. Probably the most important part of the quadratic formula is this thing that we call the discriminant. The discriminant is the part that sits underneath the square root. It is b squared minus 4ac. And what it does is it tells us the nature of the types of solutions. Maybe you remember from your previous class, if you see something that's x squared, it makes a shape. You may know what we call that shape? So the P. Parabola. Makes a parabola. And so you can really have three types of parabolas. Here's parabola number one. Parabola number one looks like that. And if you notice, it crosses through the x-axis twice. We're also going to be talking about this 2 units from now, so this is an important one to kind of lean into because you'll use this as we move forward. So it has two solutions that I circled in green. Two solutions. And if that's the case, then b squared minus 4ac, that piece underneath the square root, it is positive, or it is greater than 0. Okay? So it ends up being the square root of a positive. If you have the square root of a positive, it's going to be two solutions, meaning the parabola crosses the x-axis twice. Suppose that the value of the discriminant is 0, so you end up with the square root of 0 underneath. Okay? Then there would be just one solution. And that would mean that the parabola would look like this. Okay? Where it just touches the x-axis at one point and then heads off from there. And suppose that it was negative. Suppose you had a square root of a negative. Can't take the square root of a negative. That's what we call imaginary numbers, which some people think are silly. Imaginary numbers is what makes electricity possible. We didn't have imaginary numbers. Everything you have in life would have to have a battery as opposed to outlets that we have. So we like imaginary numbers. There are no solutions. Why? Because that would be a parabola that looks like this. If you have a parabola that is always above the x-axis, then it never crosses and it doesn't have any solutions. So for these examples, we're just going to find the value of the discriminant and then talk about the types of solutions it has, 0, 1, or 2, and go from there. So in these situations, you need to know what A is, B is, and C is. A is the number that sits in front of x squared, which in this case is 1. B is the number that sits in front of x, which is negative 6. And C is the number at the end, which is 9. The discriminant is b squared minus 4ac. b squared minus 4ac. What do you get if you square b? 36. Minus 4 times a is 1 and c is 9. So before I subtract, I'm going to do my multiplication. 4 times 1 times 9 is 36. So I get 36 minus 36 is 0. The value of the discriminant is 0. That means if we did the quadratic formula, we would find that there would be just one solution. It's a graph that looks like that. I find that one of the biggest issues for people is that when they go through this process, notice that b is negative 6. When they square it, they get negative 36. If you square something, it will always be positive. Don't write a negative. Go ahead, try number 2 on your own. Do b squared minus 4ac, see what you get. I've got two negatives, so I get a positive 25. That means that there are two solutions. Two solutions. Are we good with that? Okay. And we're going to skip number 4. Try number 3 on your own. Try number 3 on your own. B squared minus 4AC. Yeah, now you got two solutions. Real good? Okay, flip it over. When you're working with the quadratic formula, sometimes we come to a point where you need to simplify the radicals, which is why I threw it into the radical unit. Okay? And so we want to be able to simplify some of these expressions. And I'll show you what simplifying that looks like. First of all, I want to simplify this expression of 6 plus or minus the root of 24 over 4. I have 6 plus or minus the root over 4. Okay. What is the perfect square that divides evenly into 24? 4. So I have 4 times 6. And we know that you can simplify the square root of 4 to 2. So we get 6 plus or minus 2 roots of 6 all over 4. This is not completely done. I have the part in green, I have the part in red, I have the part in blue. Okay, there's 3 terms up here. If they're all divisible by the same number, you can go ahead and divide that number out. What are 6, 2, and 4 all divisible by? 2. So go ahead and divide everything by 2, and we get a 3 plus or minus the root of 6 all over 2. And that is your answer. Try a couple more together. Do number 6 here. 3 plus or minus. What's the perfect square that divides evenly into 45? 9. So maybe you can see that you get 3 roots of 5 because it's the root of 9 times the root of 5. So we get 3 roots of 5 all over 9. So we do want that simplifying that square root part to hopefully come a little bit more quickly as time goes on. We have these 3. They're all divisible by 3. So go ahead and divide them by 3, and we get 1 plus or minus the root of 5 all over 3, and that's my result. Go ahead, do number 7 and 9. Do number 7 and 9, and then we'll be ready to actually use the quadratic formula. Yes?
Do you need an extra copy of this?
I don't have any more. Sorry. Are we good with 7 and 9? Any questions? Going once? Sir?
Number 7, can't you divide that by?
You can, but notice that there is no number in front of 5 that's divisible by 3. So it has to be all of them. And let me show you for a second here. When I get this, what I'm actually doing is factoring a 2 out of the top to get 3 plus or minus the root of 5 over, and I'm factoring a 2 out of the bottom. Those are the 2's that can reduce. But after that, you cannot reduce the 3 and 6 because there's addition and subtraction there. So therefore we can't. Has to be a number in front of both terms. Okay, good question. All right, number 11 and 12 is where we go today. Solve using quadratic formula, and this is what you're going to be working on your assignment today, and then we'll cover the next piece tomorrow and Monday. A, B, and C. A is 1, B is -3, and C is -18. The quadratic formula, I'll write it down here so everybody can see it in case you haven't memorized it. -b plus or minus the square root of b squared minus 4ac, all divided by twice the a value. So x equals, what is -b? +3 plus or minus the square root of, what is b squared? 9 minus 4 times a is 1 and c is -18. All divided by twice the a value. The quadratic formula used to look really bulky back when you were in 9th grade. 8th grade, we want to be not as bulky today, be a little bit better. How many negative signs do I have underneath the square root? 2. So that's going to switch to positive, okay? So we're going to subtract a negative, so I can just change that to positive. So what I need to do is 9 plus 4 times 18. 4 times 18 is 72, and 72 plus 9 is 81. And so I get 3 plus or minus the root of 81 over 2. For all the ones you get today in your assignment, you're going to have a perfect square sitting in this spot. Because what is the square root of 81? 9. It is 9. So you get 3 plus or minus 9 over 2. So this simplifies very, very easy. We have 2 answers. What is 3 plus 9? 12 divided by 2? 6. 6 is one answer. I do the other one by doing 3 minus 9. -6 divided by 2, -3. So for today, you're going to come out with integers as your answer, whereas tomorrow we're going to come out with radicals that don't simplify as well. Okay. We'll try one more together, and then you guys can I'll show you the 4 problems in your assignment you can start working on. X is equal to, what is -b? +11 plus or minus the square root of -11 squared. 121, go Miss Wallace. Minus 4 times a times c. What goes on the bottom? Not 2, but 4, because it's 2a. 2 times 2 is 4. So on the test, I get to give you 1 point if you set up the quadratic formula correctly. In order to get the next point, you got to be able to simplify the discriminant. So x is equal to 11 plus or minus the square root of, what is 121 minus 40? 81 again. All over 4. Or 11 plus or minus 9 over 4. If you get to that point, I could give you a second point, okay? You actually evaluated the discriminant. Now to get your third point, you need to be able to come up with the 2 solutions. 11 plus 9 is 20, and 20 divided by 4 is 5. And 11 minus 9 is 2, and 2 divided by 4 is 1/2. So this is not an integer, but it is a rational number, meaning it can be expressed as a fraction. So all of your answers today are going to come out to either be integers or fractions. You're not going to come out with anything like this, 3 plus or minus the root of 17 over 2. You're not going to get anything like that today. That's what we're going to look at tomorrow. Okay? Tomorrow, all we have to do is the last 2 examples. We don't have to do all the front work, so it goes a little bit more quickly. Okay, so you're going to give a decent amount of time tomorrow or Monday to be able to work. If you look at your assignment, what I want you to do is circle the following, okay? I want you to circle hold on, let me look at it. Problems 3 and 5. 3 and 5. Those are good ones for you to start working on, okay? You could actually get those 2 done before the bell goes, but those are answers that end up as rational form.